Hello. In previous video, we solved two questions of LCM method, which was least cost method, and one question of VAM method, which was Vogel's approximation method. In least cost method, we calculated total transportation cost with the with choosing the least cost from the matrix table, and then we started allocating it, and then after that, when we found out the allocations, we multiplied it with the cost, and we found the total transportation cost for our LCM method. Now, for Vogel's approximation method, we approached we took approach of different method where we had to solve using penalties. In Vogel's approximation method, we find out penalties for each and every row and each and every column, and then we see the highest maximum penalty there, and we allocate the uh, uh, lowest allocate the allocation where we have lowest cost in the maximum penalty we found. But how do we find out max of penalties for each row and each column? We do it with uh, finding out the two lowest costs of each row and two lowest costs of each column. Example, in the previous question as we did, we had in factory 1 lowest cost as the total no, the transportation costs as 1214. So in that, the lowest cost was first lowest cost was 1, and the second lowest cost was again 1. So the difference between them was 1. So we wrote the penalty as 1. Similarly, in the second row we had 3, 3 and 2 and 1 as the cost in the cost matrix table, but here the lowest cost is 1 and the second lowest cost is 2. So we found out the difference between those two. Then we wrote the penalty. Again, we had to do with the third row also, and then with the fourth row, then the with the columns also, we are supposed to do the same. Where for example, in D1 column, we had 1 as the first lowest cost and 3 as the second lowest cost. So we took out the difference where we got 2 as the low difference. And then after finding out the penalties, we saw the highest penalty where we are getting. Where we got the highest penalty in the same column or in the same row, we have to find the lowest cost, and in that we have to allocate the maximum allocation possible. So when we find allocate the maximum allocation possible, either the demand will become 0 or supply will become 0, or both of them will become 0 sometimes. So that time we have to cancel the row as well as the column, whichever becomes 0. Then to move on to allocate the second allocation, we have to calculate the penalties again for the second time. So when we calculate the penalties for the second time, we have to ignore the cancelled out columns and rows. And similarly for the third time, fourth time, and fifth time, as many times we calculate the penalty to allocate, that many times all we have to ignore the whichever columns gets cancelled out. Then after the allocations at the end, demand and supply, everything will become 0, which means everything will get allocated. Then only the answer is correct. Then uh, Then to find out the total transportation cost, which is basic feasible solution, we multiply the we multiply the cost into the allocated cost. So in the cost which where we have allocated, there only we have to, that cost only we have to multiply with the allocated cost. After multiplication, we have to add all those costs. Maybe we would have got 6 allocations, then we'll multiply those 6 with their respective costs and we will add those, then we will get the total transportation cost. Now we will do the second problem of penalty method, which is Vogel's approximation method. The second question is, second problem, now the second problem we have is of penalty or Vogel's approximation method. We have 5 rows and 6 columns. We have supply and here demand. We have destination 1, destination 2, destination 3 and destination 4. Here we have factory 1, factory 2 and factory 3. So the question we have is, if in F1 D1 we have 6, F1 D2 we have 3 and F1 D3 we have 5 and in F1 D4 we have 4 and supply as 22. In F2 D1 we have 5 and F2 D2 we have 9. In F2 D3 we have 2, F2 D4 we have 7 and supply as 8. In F3 D1 we have 5, in F3 D2 we have 7, in F3 D3 we have 8 and in F3 D4 we have 6 and supply is for 15. Now we have demand as 9, 12, 17 and 7. Now first, what is the first step here? We have to see whether the demand is equals to supply or not. So how do we see that? We add all the supply costs, all the supply and all the demand and we see they are equal or not. So adding supply 22 plus 8 plus 15, we get 45 and adding demand 9 plus 12 plus 17 plus 7, we get 45. That means demand is equals to supply 45. That means we can proceed with the question and we can find out the solution here. So how do we find out solution? We have to make a matrix table, but it is a little bit different from LCM and NWCM method. Here we have to draw box where we have 5 columns and 6 rows, where we have destination 1, destination 2, destination 3, destination 4, and supply. Here we have factory 1, factory 2, factory 3, and demand. Now we have the all the costs we have to write in the smaller boxes, which means for F1 D1 it is 6, for F1 D2 it is 3, for F1 D5 it is 5, for F1 D4 it is 4, and supply is 22. Now for F2 row we have F1 D1, F2 D1 as 5, F2 D2 as 9, F2 D3 as 2, F2 D4 as 7, and supply as 8. Now F3 D1 as 5 and 7 for F3 D2, 8 for F3 D3, and 6 for F3 D4. And we have supply as 15 here, and here demand as 9, 12, 17, and 7. Now to highlight, I'll write this is 22, this is 8, this is 15, 9, 12, 17, 7, and total is 45. Now how we go about solving the penalty problem? We have to draw penalty columns and rows. As I already said, it is not necessary to draw, but it becomes easy when we draw penalty lines, rows and columns. So here we have penalty rows. Here we have columns for penalty. Now how we find out with the penalties is we have to see the least cost in every row, which means in F1 row we have to find out the least cost. Which one has the least cost here? First least cost we have in F1 D2, which is 3, and second least cost we have here is in F1 D4, which is 4, which means the difference between them is 1. Now for the second row we have the least penalty as 2 in the least first penalty as 2 in F2 D3, and 5 as second least penalty, which is in F2 D1, and the difference between them is 3. Now in F3 row we have 1, it is 7. In F3, we have first lowest cost as 5 and second lowest cost as 6, which is in F3 D1 and F3 D4. So difference between them is 1. Then while moving on to column wise cost penalty finding, uh, we have uh, 5 as the first least cost and again 5 as the second least cost, which means the difference is 0. Then in D2 column we have 3 as the first least cost and 7 as the second least cost, which means 4 is the difference. Now in D3 column we have 2 as the first least cost and 5 as the second least cost, which means the difference between them is 3. Now in D4 column we have 4 as the first least cost and 6 as the second least cost, which means the difference between them is 2. Now, which one has the highest penalty here? We have 4 as the highest penalty. Now, in the D2 column where we have highest penalty, which one has the lowest cost here? The F1 D2, which is 3 as the lowest cost. Now, how much can we allocate here? We can allocate maximum 12 because we have 12 as the demand, although 22 is the supply. 12 is the maximum allocation can be done. Now the 12 becomes 0 and 22 becomes 10. Now where the demand has become 0, so we will cancel the demand destination to column. Now moving on to the second allocation. First we have to find out penalty again. And now when we are finding out penalties, we have to ignore the column or row whichever is cancelled out, which means we have to ignore the D2 column. Now how much we will get the least cost here? Which is the least cost here? We have 4 as well as 5 has least cost. So the difference between them is 1. Now in the second row, we have 2 as the first least cost and 5 as the second least cost. So the difference between them is 3. Now in F3 column, we have first least cost as say 5 and second least cost as 6 again. So we will write 1 as the difference. In D1 column, we have 5 as the first least cost and again 5 as the second least cost. So the difference will become 0. The difference is 0. So we'll write 0. Here D2 column we have cancelled it out. So it is nil. In D3 column we have first least cost as 2 and second least cost as 5. So the difference is 3. In the D4 column, we have first least cost as 4 and second least cost as 6. That means the difference between them is 2. Now, which is the highest cost here? We have two high. Which one is the highest penalty here? We have two highest penalties, which are 3 in D3 column and 3 in F2 column. Now we have to see which uh, row or the corresponding the penalties row or column, which one has the lowest costs. In F2 row where the maximum penalty is there, we have 5, 9, 2 and 7. And in D3 column where we have maximum penalty 3, here we have 5, 2 and 8. That means if we take 2 uh, as the lowest cost, we get the uh, if we take 3 of the penalty of F2 row or D3 rows 3 as penalty, we have to choose 2 itself for if we choose any of this. So then now we have to see how much can we allocate here. We can allocate only 8. If there was instead of 2 here in the F2 D3 column, we had in F1 D3, we would have gone with the D3 column and we would have allocated in F1 D3. Now, as if both the way we go, we are getting 2 as the minimum cost. So we can choose any of the penalty as maximum and allocate here how much ever the maximum we can do the allocation. So here we have supply as 8 and demand as 17. So we can allocate only 8 as full 8 of supply. So supply becomes 0 and here the demand becomes 9 in D3 column. So when the supply became 0, we cancel the F2 row. Now we are only left with F1 and F3 row and D1 and D3, D4 column. Now when we are finding out next penalty, we will ignore D2 column and F2 row. That means for F1 row, we have lowest cost and the second lowest cost as 5 and 4 again. So the difference between them is 1. Then for the second, it is nothing, so it is nil. We cancel it out, so it is nil. For F3 row, we have 5 as the lowest cost and second lowest cost is 6. So the difference between them is 1. Now in D1 column, we have 5 as the first lowest cost and 6 as the second lowest cost. So the difference between them is 1. Now in second D2 column, uh, we have nothing, so it is nil. In D3 column, we have 5 as the first lowest cost and 8 as the second lowest cost. So difference between them is 3. Now in D4 column, we have 4 as the first lowest cost and 6 as the second lowest cost. So the difference between them is 2. So, which is the highest cost here, highest penalty here? We have 3 as the highest penalty in D3 column. That means we have to see for the lowest cost in D3 column, which we have is 5. So we have to allocate in F1 D3, which means how much can we allocate here? We have 10 in the supply, but demand we have only 9. So maximum we can allocate is 9. So we allocated here. Now D3 became 0 and supply became 1. Now as D3 became 0, we cancel this column out. Now we are left with D1 column, D4 column and F1 and F3 row. Now again we have to find out the penalties. Now for penalty we will ignore D2 and D3 column, which means we have left with D1 and D4 where we have 4 and 6 as the lowest costs. The difference between them is 2. For second row, it is nil. And for the third row, we have 5 and 6 as the lowest cost, which means 1 is the difference. Now, in the first column, D1 column, we have 1 as the low or difference as the lowest cost is 5 and 6. Now the second column is cancelled out, so it is nil, and the third column is also cancelled out, so it is nil. Now the D4 column we have 4 and 6 as the lowest cost, that means 2 is the difference. Now which one is the highest penalty here? We have 2 here in the F1 row and 2 here in the D4 row. Here also we can see that 4 is the lowest cost. In F1 row we have 4 as the lowest cost, and as well as in D4 column where we have highest penalty, we have 4 as the lowest cost. That means we have to allocate here in the 4. where we have 1 in supply and demand as 7. So we can allocate only 1 here. So demand became 0 and supply became demand became 6 and supply became 0 here. Now we have 0 as supply, so we will cancel the F1 row out. Now we are remaining only with F3 row and D1 and D4 column. But in D1, D4, we are left with only one cost, so we can't find out the penalty there. So it is nil for every column and nil here for F1 and F2 row. And here in F3 row, we have 6 and 5 as the penalty cost, and the difference between them is 1. Although it is um, seen that only 2 are left and the penalty is 1 only, but we have to write the penalty, then only we have to solve. 1 we wrote, then in this we have to see the least uh, cost, which is 5 here, and how much can we allocate here? We can allocate only 9. So we allocated 9 here as demand is 9. Then the demand became 0 and here the supply became 6. So we cancel the D1 column out. Now where the 6 is remaining in D4 F3, we have left with 6 demand and 6 supply. That means we will allocate 6 here. Then the demand also becomes 0 and supply also becomes 0. That means we got the answer properly. Now, what is the next step here? Next step is we have to find out the total transportation cost. How we do that? For that, we multiply the cost into allocated cost and we add all the allocated cost which were multiplied with the costs, which means basic feasible solution is equals to which means basic feasible solution is equals to 12 into 3 from F1D2 plus 9 into 5 from F1D3 plus 1 into 4 from F1D4 plus 8 into 2 from F2D3 plus 9 into 5 from F3D1 plus 6 into 6 from F3D4. We have totally 6 allocations here, which means after multiplying, we get 36 plus 45 plus 4 plus 16 plus 45 plus 36, which means when we add all this, we get the total transportation cost 36 plus 45 plus 4 plus 6 plus 45 plus 36. We got rupees 182 as the total transportation cost. Now we have to check the non-degeneracy. For that, what is the formula? We have m plus n minus 1, which should be equals to 1, 2, 3, 4, 5, 6. We have 6 allocations, so it should be equals to 6. We have totally 3 factories and 4 destinations. That means 3 plus 4 is 7 minus 1, it is equals to 6. That means it is non-degenerate, which means the allocations are according to the uh, allocations which are required in the question. Now, uh, as we solved two questions of each of the method, NWCM, LCM, and as well as Vogel's approximation method, we we can tell that Vogel's approximation or it consumes little bit more time, but Vogel's approximation method only is used in future problems because it gives the lowest transportation cost. First, NWCM method, it gives the transportation cost, but it gives the highest transportation cost. Then when we did with the LCM method, it gives the little lesser than the uh, NWCM method, but it is more than the Vogel's approximation method, the transportation cost, which is its total transportation cost. But then the last method where we found out with Vogel's approximation method, the method gives the lowest total transportation cost. That we will learn how we get lowest in the next question, where we will do the three methods with the same problem, where we will solve NWCM, LCM, and uh, Vogel's approximation VAM method to in with the same problem. Now we'll move on solving the question of all the three methods. The problem with all the three methods. Now, now for LCM, NWCM, LCM, and VAM. We will use the same question and solve all the three problems with it. All the three methods. So first we will write down the question here. We have 4 columns, 5 rows, and 7 columns. We have supply here and demand here. We have 5 destination: destination 1, destination 2, destination 3, destination 4, and destination 5. Destination 5. We have factory 1, factory 2, and factory 3 here. So the question goes like this: 5 in F1D1, 7 in F1D2, 10 in F1D3, 5 in F1D4, 3 in F1D5, supply as 5. Now F2D1 8 and 6 in F2D2, 9 in F2D3, 12 in F2D4, 4 in F2D5, and supply as 10. Now we have 10 in F3D1, 9 in F3D2 and 8 in F3D3, 10 in F3D4, 15 in F3D5. We have supply as 10. Now the demand is 3, 3, 10, 5, 4. Now what is the first step we do? We first see whether the supply is equals to demand or not, where we have 10, 10 and 5 as the supply. Here we have 25. Here in the demand, 3 plus 3 is 6, plus 10 is 16, plus 5 is 21, plus 4 is 25, which means demand is equals to supply. Now we can move on with solving the problem. So we will solve the same problem with NWCM method, LCM method and VAM method. So first we will see NWCM method. As I already said, it gives the total transportation cost, but it gives the highest total transportation cost. So how we go about that is NWCM. We have we have 5 rows and 7 columns. We have supply here and destination here. We have destination 1, destination 2, destination 3, destination 4 and destination 5 and 3 factories. And we have cost as 5, 7 in F1D2, 10 as F1D3, 5 as F1D4 and 3 as F1D5. Then also we have 8 as F2D1, 6 as F2D2, 9 as F2D3, 12 as F2D4 and 4 as F2D5. Then we have 10 as F3D1, 9 as F2D2, 8 as F2D3, 10 as F2D4. Sorry. 8 as F2D3, 10 as F2D4, 15 as F2D5. Now we have 3, 10, 5, 4 as demand and supply as 5, 10 and 10. This is demand, not destination. We have demand here. Now, as we already saw, the demand is equals to supply. So 25 here. Now we have to solve this with NWCM method, which means northwest corner method. So which is the north corner side we have? Which is we have is F1 D1, which means we have to start allocating F1 D1 cost. So how much we get here? We can allocate if the 3. We can only allocate 3 here because supply we have 5 and demand we have only 3. So we allocated 3 here. So the demand becomes 0 and supply becomes 2. Now As the demand became 0, we cancel the demand column out. Now, which is the next north corner side? As we have to ignore the D1 column whole totally, so we have D2, which is F1 D2 as the next uh, north side cost. So we will allocate F1 D2, where we have demand as 3 but supply as 2. So we can only allocate 2 here, 2. And here the demand will become 1 and supply will become 0. So we cancel F1 row out as the supply has become 0. Now the next, which is the next north corner side, we have F2 D2 as the next, which means we can allocate here 1, only 1 because demand is 1, here 1, and the supply becomes 9 here, and here 1 becomes 0, and we cancel D2 column out. Now, which is the next north corner side? We have 9 as the next north corner one. So here we can allocate only 9 because supply is 9, although demand is 10 there. So demand becomes 1, supply becomes 0. So we cancel F2 row out. Now, which is the next west corner side? Is 8 is the northwest corner side. So which means we will have to allocate here. We can allocate only 1 here. So we allocated 1. The demand became 0 and supply became 9. Now, as we have allocated here, the F2 row became 0. F or D3 column became 0, so we will cancel D3 column off. Now we have F2 D4 as the northeast um, corner one, so we will allocate here. How much can we allocate? Total 5 demand is there, so we can allocate all 5 demand, and the demand becomes 0, so we cancel D4 out, D4 column. Then we have only 4 remaining in demand as well as in supply. So we cancel the 4 and 4 of demand and supply. We allocate 4 here in the F2D5 column. Now, to find out the basic feasible solution, we have to multiply the total to find out the total cost, we have to multiply the costs into the allocated costs, which is 3 into 5, which is in F1D1, plus 2 into 7, which is in F1D2, plus 1 into 6, which is in F2D2, plus 9 into 9, which is in F2D3, plus 1 into 8, which is in F3, F3D3, 1 into 8, plus 5 into 10, which is in F3D4, plus 4 into 15, which is in F3D5. After multiplying, we get 15 plus 14 plus 6 plus 81 plus 8 plus 50 plus 60. So, which is equals to 15 plus 14 plus 6 plus 81 plus 8 plus 50 plus 60, which is equals to 234 rupees, which means we are getting total cost of transportation in NWCM method as 234 rupees. Now let's see how much we will get in LCM method. How much transportation cost we get in LCM method. We have here we have 5 rows and 7 columns. 7 columns. We have same destination 1, destination 2, destination 3, destination 4 and 5. We are taking the same problem here which I have written in the north corner side, F1, F2 and F3, which I used for solving NWCM method. This is LCM. Here it is demand. So we have 5, 7, 10, 5, 3 as the F1 cost and total supply is 5. Then we have 8, 6, 9, 12 and 4 as cost and supply as 10. Now we have 10, 9, 8, 10, 15 and supply as 10. We also have 3, 3, 10, 5, 4 as demand. Now total of supply is equals to total of demand, which is 25. Now we will solve this with LCM method. Method means least cost method, where we see the least cost in the cost and we start allocating there from there. So which is the least cost here? We have 3 as the least cost in this. So how much can we allocate here? We have demand as 4 and supply as 5. So we can allocate only 4 as allocation, which means demand becomes 0 and supply becomes 1. Now we will cancel the D5 column out. Now, which is the next lowest cost? We have 5. 5 as the next, no, 3, 4. Yes, 5 as the next lowest cost. So which one we will allocate? We have uh, here 5 and here 5. 2 5 we have in F1 D1 1 5 we have, and in uh, F1 D4 1 5 we have. We can allocate anywhere where we cannot allocate anywhere. We have to see where we are getting maximum allocation. Here we can see that we have one as supply remaining, where we in the F1 row. So if we take anywhere D1 column or D4 column, we would have to allocate only one itself. So we can take any 5 in this. If we had supply as something else, maybe 4 or 5, we would have 4 supply as 4, we would have gone for D4 exactly, because we can allocate supply 4 as um, allocation here, because demand we have 5 here in the D4 column. Here in the D1 column we have only 3. So if we take F1 D1 and allocate it there, we can only allocate 3 here. So we would have taken F1 D4 5, and we would have allocated 4 there if we had supply as 4. Now as we have 1 as supply, so we can take any one. So I will take F1 D1 and allocate there 1. So this demand becomes 2, and here supply becomes 0. So the F1 row is cancelled out. Now which is the least cost here? We have 6, which is in F2D2 as the least cost. So how much can we allocate here? We can allocate only 3, as we have demand only 3. So we allocated 3 here. The demand got cancelled and became 0, and we are here supply is remaining 7. Now we cancel D2 column out. Next, we have the lowest cost is 8, but we have two 8s here. Which one can be allocated more? We can allocate here in F3D3, where we have 10 as demand and 10 as supply. We can allocate here more, because in F2D1 we have only 2 demand and 7 supply, but we can allocate only 2, right? So in D3 F3 we can allocate full 10, supply full 10 and demand full 10. So we will allocate here 10, and we will cancel this 10, uh, this 10 0, and the demand supply also 0. So we cancel out the F3 row as well as D3 column. Next, which one we have the least cost here? We have uh, we have least cost as 8 here, and we can allocate only 2 there. So we will allocate 2 here, which means this 2 becomes 0, and here the supply becomes 5. So now we will cancel the D1 row, D1 column out. Next, we have only 12 remaining, where we have only supply also 5 and demand also 5. So we'll allocate 5 there. Now we have to find out basic feasible solution, which is equals to, we have 1 into 5 in F1D1 plus 4 into 3 plus 2 into 8 plus 3 into 6 plus 5 into 12 plus 10 into 8. We have 2, 3, 4, 5, 6. 6 allocations. So how much we get here? We have 5 plus 12 plus 16 plus 18 plus 60 plus 18. So when we total this, we get 5 plus 12 plus 16 plus 18 plus 60 plus 80. We have 191. We have total transportation cost as 191 rupees, which means, as I said, northwest corner method gives the highest transportation cost. Then comes the LCM method, where least cost method, where it gives the transportation cost lesser than NWCM method, but it is more than um, VAM method. VAM method we will see in the next video. Thank you.